Hello and welcome. So in this video, we are going to be talking about Cambridge 2024 October November 9618 paper 4.3. This is paper 4, so let's go ahead and get started. So a program sorts string data using different sorting methods. The text, so the file is going to be taking data.txt. So this will be your source file. You can download it online or from my GitHub. That's going to be in the description. So with that being said, let's go ahead and get started with the code. So I am going to go ahead and open this folder in Visual Studio Code and take this, drag it, and open it. So once I have the folder right here, what I'm going to do is create a new Python file named question1 underscore n24.py. Okay, so let's go ahead and just create this folder. So increase my font a little bit. Okay, so it has a local array of strings that can store 45 items, reads each line of the data and stores in their array and returns the array. So the procedure read data. So we're going to be starting off with define read data. It doesn't take any parameters, so I'm going to create a local array of name R. And during the exam, what we can do is we can automatically just do a hashtag and just say 45 elements. You could also assign it in such a way that you do, like, let's say times 45, but it's incorrect to kind of keep your array kind of empty. So you could put in a empty string times 45. That should do the job as well. But I'm just going to do like this hashtag 45 elements. Okay. Now what I want to do is we want to go to open file. So you could do with statements, or you could use the try except statement. That's also going to work. We just need to go ahead and open the file and then do it. So I'm just going to use with open data.txt. I want to just read from this file, so .r as file. We are going to be going ahead and doing it like that. So you're going to read one line at a file at a time. So we're going to do file dot read lines dot, and then you're going to do split lines. So, okay, read lines is going to read one line. So what we want to do is read, and we also want to do is split lines. Sorry. So what we want to do is we want to read from the file and we want to split the lines, and we're going to use array extend function. The extend function is going to allow us to create a append to the array without creating a sub array. So if you're using dot append, then what's going to happen is it's going to work, but it's going to create another sub array within this array. And that's going to be a problem if you're trying to read from this array and using any other built-in functions, because we are trying to compare strings in this case. It's going to be, it might pose an error. Okay, so you're going to go ahead and use the extend function in this case, and then put line in extend. Okay, it's just going to be adding it to the end of the array. With that being said, all we want to do is we want to do file.close. So using the with statement, we do not need to go ahead and use a loop. That eliminates the use of a loop. And all we need to do is just now do is return array. Okay, so that's the first code. Reads each line and then it returns the array. Okay. The next question says the function format array takes an integer of array strings as a parameter and concatenates the contents of the array into one string with a space between each element. The function then returns the concatenated string. So what we want to do is we want to write format array, and it takes input, or sorry, take as an array of strings. So we want to return this over here. So we just want to do is let's just do R, and then we want to do is we want to put in, so let's say conc, it's going to be the concatenated string, and then we want to go ahead and loop through it. Okay, so I want to know the length of the array to know how many strings are there. So length of R, so for I in range, sorry, in range of n, what we want to do is we want to go ahead and take conc equal to conc plus, we want to take the array element, so we want to go ahead and do this conc array index I, plus we want to go ahead and put in a blank space. Okay, that's going to be concatenating it. And then finally, we exit and we just return the concatenated string. So that's going to be our final answer. Okay, I apologize for the glitch over there. So the main program reads the data. So it's going to be calling read data first and stores the returned array. It calls format array with the returned array and outputs a return string. So write the program code to amend it. So it stores the return array. So what we want to do is we want to name, let's say, a main program variable, and then we want to first go ahead and call the read data. And then what we want to do is it just calls format array with the return outputs a return string. So we need to do a print statement, format array, and then on this we pass on data array. So that's going to be going ahead and printing the return concatenated string. Let's just test the program for testing purposes. Let's see. So there we go. It returns the entire string. I don't want to go and read through it, but it does put a space between each of them. So I think it's fine. Right? So let's move on to the next question. Oh, it already told us to test my program. Okay, so the function compare strings will take two strings or parameters, compares each of the string one string at a time to identify which string comes first alphabetically. So if you're using Python, this it makes the job easier because in Python you can just directly compare each letter on there. And if the first two characters are the same, the second characters are checked in the same string. This continues until the two characters are different. The function returns 1 if the first parameter comes before the second alphabetically, returns true if the second parameter comes, first alphabetically. Okay. Write program to create compare strings. Assume that all strings are in lowercase. So again, we don't need to kind of go ahead and use any built-in function. Assume the difference in two strings will always be identified before the end of one of the strings be reached. So even if they have mentioned this to us, we could go ahead and use a validation check, but again, you really don't need to if you don't want to. But we're just going to go ahead and do it anyways. So we're going to be creating the program called compare strings. It'll take two string parameters. So let's go ahead, def compare strings. Then we're going to be doing it take string 1 and string 2 as parameter. Okay, and then if length of string 1 is greater than length of string 2, we want to go ahead and create n equal to length of string 2 because we're going to be reaching the end before the end of one of the strings, right? So that means we got to take the length or run a loop till the kind of end of the shortest string. So else n is going to be length of string 1. Okay, with that being said, now we need to go ahead and iterate over. But we don't want to iterate throughout the entire string. Once we find a discrepancy that means like one is greater than the other, we could just terminate. So we're going to be putting a counter, which I'm going to call I. You could also call it counter, up to you. Okay, let's call it counter. And I'm also going to be going ahead and let's use something called flag being initially true. So what we want to do is, or you couldn't even use flag, or we could just easily do while 1. That means it's going to continue, or you could just do while true. So it's going to just continue the loop like that. So we're going to do is while true. We could also go ahead and do while, since we know that like we are going to be finding a string that's like greater than the other or not, we could have used the flag approach, but again, it's a little bit more appropriate to do while counter is less than n. That means we have reached the end of the shortest string. All right. So if string, so in this case, we got s1. So you could do like we have if, so in this case, s1i, that's going to compare the first index. So we are going to be doing is s1 counter greater than s2 counter. Okay, so that means it's the first string we're talking about. So we just want to go ahead and do return 1. Else, we just go ahead and do return 2. Okay, so that's the only thing we need to do in the entire thing. And obviously we need to go ahead and increment I out of it. So I is going to be plus equals 1. You could also go ahead and do an else if statement, because what if they're equal? So if they're equals, we have to go ahead and do elif s2 counter being, oops, sorry. S2 counter being greater than S1 counter, we want to go ahead and do is return 2. Okay, so with that being said, this is going to be the compare string function. I hope I'm recording. Yeah, so this is going to be the compare string function. So we're going to be comparing the strings in this case, and obviously we increment I in the loop. Oh, sorry, I'm giving it as an I. It should be counter. Sorry. uh Oops, I was hit the debug button. Okay, so let's move on to the next question. So the next question is going to be the function bubble sort takes an array of strings of parameter and sorts the data into ascending alphabetical order using bubble sort. The bubble sort uses compare strings to compare each string. So we're going to be having to go ahead and use this function that we just created in the bubble sort algorithm. The function returns the sorted list. Okay, write the program for a bubble. So we want to go ahead and do is def bubble. We are taking an array as a parameter. So the length of the array is going to be n length of r. Okay. Now what we want to do is we want to go ahead and create a bubble sort algorithm. So for I is we need to use 2 loops. So we need to use a nested loop. So I range n, and so that we don't go out of bounds, we have to use for j in range. So we got to use nested loops. So what we're going to do is n minus 1, and then we've got to go ahead and take the value. Okay, so or you could even call it flag, whatever you want to call it. So the flag is going to be we use compare strings, and then we call compare strings with array index of I and array index of I plus 1. That's going to be the second string. So if flag equals 1, that's when we know that if flag equals 1, that's when we know that the first string right here is going to be greater. So that's what we want to do the swap, right? Because only the first string matters. If the second string is greater, like if the value is 2, it's not going to matter because we don't need to swap it. It's already in a sorted format. So when you're calling compare strings and we're taking these two, if we get the value 1, that means this is larger alphabetically, so we just need to swap between them. So since we're using Python, we could just do array I, comma, array I plus 1 is going to be array I plus 1, comma, array I. That's just done in one line in Python. If you're using something like C, then that's probably going to take a few lines. Okay, so once we're done with the for loop, that's pretty much it. Then we just go ahead and do return array. So we want to return the sorted string right here. I mean the sorted array, sorry for that. So once that's done, let's take a look at the following part of the question. Call bubble, call format array with the sorted array output of the string and test your program. So what we want to do is let's keep this. Then we're going to be going calling bubble sorts. We're going to do is bubble, and then we're just going to naming it. We have to data array, and let's store this in sorted array. So now what we do is we take this line right here and we just recall this with sorted array. That's it. So we call this with sorted array. All we just do is run the Python. Okay, so it says list index out of range j and my, oh, sorry, I apologize. I'm actually calling it with I instead of j. Should have realized this. So j, 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 uh, j. Okay, so let's rerun the code. So this is the not sorted, and you can see we are amber, aqua, azure, beige, black, bronze. So it does look sorted in my opinion. You could just match it with the mark scheme or just copy this and see if it's sorted. But I think they look sorted in. So that should be enough for the output. Okay, so that's it. I think we're done with question 1. We can move on to object-oriented programming for question 2. Okay, so let's go ahead and do new file. Question 2 underscore n24 dot. Okay, so in question 2, let's go ahead and see what they have asked us for. A computer program is designed to simulate horses doing show jumping. Okay, the following in the show jumping horses, the jump over obstacles called fences. A horse successfully jumps a fence if it does not knock the fence down. Okay, the program is written in object-written programming, and a class called horse stores the following data: name, max height of the fence, and percentage success. Okay, so stores the name given to the horse, stores the maximum height in centimeters of the horse that can jump, stores the percentage chance of a horse not knocking down a fence. For example, 70 represents 70% chance of jumping a fence successfully. So we gotta go to is constructor initializes name, max height, and percentage success to its parameters, returns the name of the horse. Okay, so returns the name of the horse, get name, returns the maximum height the horse can jump, and success calculates and returns the percentage chance successfully jumping a specific fence. So this is going to be a method of the class, and I think these are the get methods of the class. Okay, so we're going to go and do a class called horse. And in this class, we're going to have def init. So under the self, we need to use the name parameter. So we're going to put it as name p. We have max fence height p. So these are the following parameters. Oh, we also have percentage success. So I'm just going to copy this. Percentage success p. So over here, we want to create some private attributes. So I'm going to start off with name. Sorry. Name p, self underscore max fence height, and self dot percentage success is going to be percentage success p. Okay, that should do it. All right. Write program code to declare the class horse and its constructor. Do not declare the other methods. Use your programming language to appropriate constructor. All attributes must be private if you're using Python. Okay. The get methods get name and get max height max fence height each return the relevant attributes. So we just need to do the get methods. So we need to do is def get name. This is obviously a method of the class. So we need to use self. So self name and def. I think it's called get max fence height. I'm just gonna copy this. Good in self. Max fence height. There we go. Okay, so that's done with the get methods, relevant get methods. So an array of horses stores objects of type horse. So the program has two horses specifically. Okay, so the horse named Beauty can jump a maximum height of 150, has a success percentage of 72. The horse named Jet can jump a maximum height of 160 and a success percentage of this. Write a program code to declare the array of horses. Okay, so now we need to work with the main program. So we need to do horses. That's going to be an array. So in this case, we're just going to do horses. Okay, so in the first instance of horses, we want to go and append horse, and the name of the horse is named Beauty in the first case. So Beauty. The next is the maximum height. That's going to be 150, and a success rate of 72%. That's going to be, in my case, 0.72. Okay. Next, we also have to do the same thing. So I'm just going to copy this line, put it here. Let's change the name to Jet, change the height to 160, and change the percentage to 0.65. Okay, so that should do the trick for the horses error. Okay, to test your program, output the name of both the horses from the array object. Okay, so let's just go ahead and output the name. So we just want to do is print horses dot so horses, the first horse is at 0 index. We want to do is get name method. Then we want to print horses 1 dot get name method. From here, if you run Python file, there we've got Jet and we've got Beauty. So that looks good to me, right? Okay, moving on to the next part of the question. The class fence stores data about the fences. Each fence has a height in centimeters and a risk number, okay? So the numbers are going to be, so the risk is 1 to 5 inclusive. Risk of 1 means the fence is easiest, and a risk of 5 means the fence is the hardest to jump. So the height is, it stores the height, and it's between 70 and 80, and the risk has to be between 1 and 5. So the constructor is, it initializes height and risk to the parameter values that's going to be given by the user, and you've got two get methods, get height and get risk. So we need to go ahead and create another class named fence. So let's call it class fence. Oh, sorry. And in it, we're going to be having the height. So we're going to go height p, and you've got risks. We've got risk p, right? So over here, we've got to do self dot init height is going to be height p, and self dot height. So we got risk. In this case, it's going to be risk p. All right, that's it. Then we got to go ahead and write the program code to declare fence and its constructor and the get method. So let's just go ahead and do that quickly. So I'm going to be defining def. Let's paste the name, get height, put the self method over here. So we want to return the height. So what we want to do is return self dot height. Similarly, we got to do is get risk. So let's go ahead and put get risk here. It's going to be returning the risk factor. So that's going to be self. That's going to be risk. Okay. So I think that creates the fence class there. Okay, all attributes must be private as usual. Okay, the array course stores 4 fence objects. The user inputs the height and risk for each fence, and these are validated before we put it in the fence array. Okay, cool. So we declare the local array course, and I think local okay, so it's in the main program. Okay, take the input data for the 4 fences. We declare the array course first of all. We take 4 inputs and loop. We do the validation check to see if it's like inclusive. So we have to be 70 to 80 and 1 to 5 inclusive. So we loop through that, and then we create an instance fence and we just append it to the array. So in this case, we just use the append function. So over here, let's just do it here. So I want to do course again, that's going to be it. So what we want to do is for I in range 4 elements, we just do 4. Okay, we first take the user input. So what we do is while true. So we want to go ahead and keep looping until like we have it right. So we take in a height as input. So int input. Let's just put this message over here, and I'm just going to take this code and copy this, and we're going to be taking another variable risk and input the risk factor, risk. So now, oops, I spelled it wrong. So now we want to go and check if we have 2 conditions of height is greater than or equal to 70. I think that's it, yeah, 70. And we have height is less than or equal to 180. So that's one set of conditions. And we have a risk that's going to be going ahead and being greater than or equal to 1, and risk being less or equal to 5. Then what we do is we break out of this loop. We don't continue, or else it's just going to continue to loop and ask us for it. Once we break out of this loop, what we want to do is we just want to go ahead and take course in the index I dot append. We can use append in this case. So course, okay, we don't need to actually do the dot I thingy because we're using append. Sorry for that. Over here, we do course. Sorry, we do fence, and then we take in the height as parameter and the risk as parameter. And I think that should do the job for us. So it appends accordingly. All right, so I'm just going to run the Python file, and it's telling me to enter height. Let's just do Okay, so we are having an issue here. It's asking us for the height again, risk. So it asked us for once, twice, thrice, and four. Okay, is the code working? So if height is greater than or equal to 70, and the height is less than or equal to, and risk is 1, and risk is 5. So if this both conditions are validated, we break out of this while loop, and then we append. Okay, looks like the code is working. Okay, great. So once we are done with that, let's move on to the second part of the question. The array core stores 4 fence objects. The user inputs the height and risk for each fence, and these are validated before the fence is created. Amend the main program to declare the local. Oh, we just did it. Sorry. Okay. The chance of a horse jumping a fence without knocking it down is calculated as follows. It's going to be giving us certain restrictions, certain constraints for the program. So if the height of the fence is more than the maximum height a horse can jump, the success percentage is 20 of the horse's percentage success. The risk does not affect this value. If the height is less than or equal to the maximum height a horse can jump, the risk gives a modifier value to multiply with the horse's percentage success, which is given in the following table right here. So for example, Jet has a percentage success of 65 and a max height of 160. A fence has a height of 140 and 3. So since it's 3, we multiply this risk factor. The risk factor is used, therefore the risk factor is used. So risk of 3 gives a modifier of 0.8. So we do 65% times 0.8, which is going to give 52. So that's 52% of the success rate of successful jumping. The method success in the horse's class. Okay. In the horse class takes the height and risk of the fence as parameters, calculates the percentage success of knocking of a fence without knocking it down, and then returns the calculated percentage success as a real number. So it returns it as a real number. So what is a real number? Real numbers are basically float numbers. But the issue is if you're using float with Python, and if there is a floating point multiplication and it doesn't accurately represent it, you're going to be running into issues. So we need to kind of round up or down this value slightly. So you're going to be using the round function in Python in order to do that. Like that's how I plan to do it. But again, there are different methods. You could just directly use the float function, int function, but we need to return it as a real number. So it needs to be decimal places. Okay, so with that being said, let's move on to the function. Success. So it's going to be taking the height. That's going to be height of the fence, risk. Okay. So what we want to do is we want to first check that if max height is less than height. So if self dot I think so max fence height is less than the height of the fence. That means we return a value with self dot percentage success times 0.2. So that's going to be 20% of the percentage success. So since I'm taking in the percentage values as decimals, what I want to do is I also want to go ahead and multiply 100 when it's returning the value out. Else, that's going to make it easier when I'm outputting. So that's going to make things a lot easier. So if risk is going to be equal to 5, then what I want to do is want to return self dot percentage success. So we first take a look at the modifier for 5. That's 0.6. So 0.6 times 100. Right. I'm just going to take this line because we need to keep repeating it. So else if risk is equal to 4. Again, we don't need to do the else if thing because we know that it's already validated in the fence function. Oh, sorry, I mean in the loop right here. But still, it's good to do it. So 0.7. So you got to do is we got to do 0.7. Else if, in this case, risk, if it's equal to 3, we go ahead and return 0.8. And else if risk is equal to 2, we return, I had it copied, 0.9, I believe. Yeah, and for 1, it's just going to be 1, so that really doesn't matter. So else if risk if it's equal to 1, then we return just multiplied by 100. So we just go ahead and return percentage success by as it is 1. So we really don't need to calculate anything over here as for now. Okay, cool. So now what we want to go ahead and do is let's read the next part of the question. Okay. So the question states that write program code to amend the main program to calculate and output the chance of the first horse jumping off the 4 fences without knocking. Calculate the output and chance of the second horse jumping for the 4 fences without knocking each fence down. All outputs must have an appropriate message including the name of the horse and the fence number. An example output of 1 horse jumping 2 fences is the horse fox at fence 1 has a percentage chance, 60% chance. The horse fox at fence 2. So it's just an example, and so on and so on. So fence 1, fence 2, and so on. So what I want to do is over here, let's go ahead and run another loop. So I'm going to go ahead and just go down and let's go ahead and run another loop. So I'm just going to do is for I in range. You could do X or whatever. Okay. So from here, let's first calculate the chances of the horse. So what we want to do is we want to go to horses, and we want to do it for the first horse. So dot horse, and then we just do success. So we need to call success, and for success, you need to do horse, and in this case, that's going to be I dot. We want to first get. That's going to be height. So get height. And for it's the same one, horse I, we need to take the risk. So what we do is get risk. All right. So that's going to be calculating and spitting out the chance of the horse. And then what we want to do is we want to go ahead and print the message, the horse, comma, and then we want to go ahead and do horse. That's going to be, we're going to be talking about, in this case, it's going to be 0. That's for the first horse in our case. Horse dot get name. That's the name of the horse, comma, at fence. So that's going to be the fence. That's going to be index plus 1 because the index is going to be starting from 0 till 3. So index plus 1 has a. So what we want to do is do chance of success. All right, so that's pretty much it. So we do it once for horse 1. So, and we do once it for horse 2. So the first case is going to be for horse 1, and for the second one, that's going to be hashtag for horse 2. Okay, so we just keep doing that in this case. Okay, so that's going to be spitting out the chances. Okay. Okay, so let's go ahead and test it out. I think we have a few test cases at the bottom, and there you go, we just have them. So let's just go ahead and run. So we got to go ahead and do the enter height. So we got to do is 152, enter the risk. It was a 5, height is 120. Oh crap. Instead of making an error, let's return. So we got 152, a risk factor of 5. We got 121 with a risk factor of 1. We got a height of 130, risk factor 3, and we've got a height of 145 and risk factor 4. Horse 0, the horse, oh, oops, sorry, that's going to be horse says because that's the array. Similarly over here, horse says. Over here, horse says. Okay, now hopefully this should work. So we go ahead and do the same 152. That's going to do a height of 5. 121. That's going to do a height of 1. And then we've got 130. That's going to be doing 3. Then we've got 145, and that's going to be going height and doing 4. Okay, this is the problem I was talking about. For using direct floating point values, we're getting 0.0 in this case, 0.54 in this case, 0.72, 0.072. So we're getting it once for beauty. Okay, something is wrong. Oh, you're doing it for the exact same horse. I forgot. So you gotta do it. Oh, you gotta change it to a 1. Really sorry for that. Let's rerun the code. Let's rerun the code. So we've got 152, 121, and then we've got 1. Then we've got 130. That's gonna be a 3. Um, I think my mouse is sorry for that. Then we got 133, and we've got 145, and a risk factor of 4. So now we've got it for jet over here, but the problem is this floating point values. So the value of chance, what we could immediately do to chance is we could round it. So we're going to do in the Python, we're going to use the round function of chance, and we're going to round it to 2 decimal places. Okay, but the problem is this is not going to work like this. So what we want to do is we want to round either this value or we want to round it here. So I think it's better to do it here. This is like a really long code. So let's put the bracket here, and I want to do a round function here, and I want to keep it to 2 decimal places. You could do it 3, I guess, or probably 1, since they haven't mentioned anything, but I think 2 looks like an appropriate number in my case. So once we're going to do that, we're going to take the 2, and what we're going to do is we're going to do 152, 5, then we've got 121, then we've got 1, then you've got 130, and then you've got 3, we've got 145, and you've got 4. And there you go. It's all rounded to specifically 1 decimal place. Okay? So that's pretty much it. So yeah. So by 2, it means actually like it's going to be only 1 decimal place after your uh, decimal point. That's going to be 1. So if you put 3 and so on and so on, so that's going to be appropriately rounded accordingly. So it means probably significant things. Okay, so with that being said, after rounding it up, the write main program to amend the main, I want to go and check the round function in Python. So doing this rounded number, this should be returning 2 decimal places, but I think it also depends on, kind of the number itself. So I don't know why it's not spitting out. Uh, so I'm doing round, if I'm not wrong. I think round function Python. So we're going to do is round function, number of digits, so parameters, digits, number of digits up to which the given number to be rounded. So the second part round function returns. So if only one is going round 15 itself, the round function always returns a number, either a float or an integer. Cool with that. So number, then it's round number, print round number. That's going to be returning the whole number. And then we got to do is this. Okay, so if we're using 2, this should return 2 decimal places. I really don't know what happened there. But I think that shouldn't be an issue because they haven't mentioned specifically what decimal places to kind of go to. Okay. Okay. So write the program to amend the main program to calculate and output the average of the horses jumping on the 4 fences without knocking each fence, the average of the total values divided by the quantity. Okay. So basically we want to take all those chances that we're getting with horses, and then we want to go and just return the average. So what we want to do that is the fox has an average of 7% chance of jumping over all 4 fences. I'll put the name of the horse that has the highest average chance of success. Assume that an average will be different, so the averages has to be different, and the outputs must have an appropriate message. Okay, so we don't need to do a check that if they're equal, write something like they're a draw or they have equal chances now, but we just need to go out and find out which is greater. So over here, once we're calculating a chance, we need a way to store that and then find the average ultimately. So we need to go ahead and let's go ahead and put in another variable. So for here, I want to go ahead and do total 1. That's for the first course. So since that's going to be a variable for the first course, in total 1, I want to go ahead and do total 1 plus chance, right? And after doing the for loop, all I want to do is I want to find the average 1. And I want to go ahead and again do the round thingy. Okay. Okay, I can do it later on as well. It really doesn't matter. So what we want to do is we just want to do total 1 divided by 4 since we're taking 4 values. Well, we're going to do the same thing for horse number 2 as well. So we're going to do it and take a chances, but this time we want to do it for a value called total 2. That's going to be equal to 0. So over here, I just want to replace it with a 2. All right. And then over here, we want to do is we want to take average 2. That's going to be total 2 over 4, since we're also taking 4 values. So now we want to go ahead and find out which one's like the greatest. So the horse, fox, and average chance. Okay. So over here, we also want to print that out. So let's print the horse. So we're doing it for horses. That's going to be the first element. Get name has an average. So then we want to go ahead and do the average. So we want to do is put average 1, but I want to take average 1 and I want to keep it to a real value. So I want to round it to, let's say, 2 decimal places. Average 2, chance of jumping over all 4 fences, right? And this could be done for, again, second horse as well. So average, this time is going to be horse 2 in this case, and this is going to be average 2 in this case. Let's get average 2 as an average. Okay, let's try running it. So I think after this, they're giving us a combination. Okay, I'm sorry. So what we're going to do is 152, 5, 121, 1, 130, 3, 145, and 4. So the horse chance has an average of 50.8 and 40 is 50.3. I think there is a 0 at the end of this. It's not rounding it up, but I don't know. All of them, they're showing a 0, so I really have no clue what's going on over there. But yeah. So we have percentage under. Okay. So basically, the horse chance an average of jumping over. Okay. So now we want to check which one has the highest. So let's go ahead and put in highest, right? So highest, let's go ahead and put it equal to 0 for now. Let's assume that a horse 1 is. So if average 1 is greater, oh, sorry, than average 2. That means horse 1 is technically kind of like highest. So what we want to do is I'll put the name of the horse that has the highest average chance. So print highest chance is equal to horses dot 0 get name, right? And then what I'm going to do is else. I think we don't need. I don't need this. So I thought we need to also print the kind of the details about that horse. Else, I just want to copy this, and we print in this case horse 1, if that's not the case. So it should be jet by default because I think I saw a higher number there. Let's run the program again. 121, 1, 130, and then we're going to put a 3. Then we have 145, and we've got a 4. So highest chance, yeah, there we go. It's up for jet. The horse jet has the average. Oh, I think I printed it between uh for in range average to. Oh, okay. So yeah. So there we go. Let's erase these. I think we don't. Okay, or you can keep that. Real doesn't matter. Okay. So that's how we're going to be logically going and doing question number 2. So let's move on to question 3 underscore n24.5. All right. So let's go ahead and take a look at the following question. So the next one is about a linked list. Okay, so I've also kind of opened this drawing area utility just to kind of represent the linked list and hopefully make this question a lot easier to understand than it looks. So let's go ahead and do this linked list question. Okay, so linked list stores positive integer data in a 2D array. So we want to implement this linked list using a 2D array. The first dimension of the linked list, the dimension of the array stores the integer data. The second dimension of the array stores the pointer to the next node of the linked list. A linked list, okay, so basically we're going to be going ahead and having this linked list. I wish I could draw some. Okay, so basically we're going to be having the data, and we're also going to be going ahead and having the basically node to the next pointer, right? So that's going to be this linked list right here. And then this node is obviously connecting to some other node that's going to be later on. So we just want to go ahead and do this. So that's going to be basically node. So if I were to do ahead and do text, this is going to be like, let's say, the first node, that's going to be 0 in the array index. That's going to store 0, and this is going to be storing 1. So this node is going to have a value of 1, and so forth and so forth. So that's going to be the visual representation of this linked list. Okay, so let's go ahead and do a linked list with no data is initialized with integer 1. The nodes are linked together as an empty list. A pointer of -1 identifies that the node is the last node. That means we can't go any further behind that. The linked list stores 20 nodes. So in this case, this linked list has a limitation of 20. The global 2D array linked list stores the linked list. Okay. Now we've got to talk about this. Linked list is initialized as an empty list. So initially the entire linked list is empty, and the data on each node is initialized to -1. Each node's pointer stores the index of the next node, obviously. Last node of the pointer, okay, so the very last one is going to have a value of -1, which indicates that it's the last node. The global variable first empty stores the index of the first element in the empty list. So first empty stores in the first element in the empty list. So we need to make sure that first empty means this area that is totally empty in the linked list. So once you start filling up the linked list, we want to keep an area of the linked list, or we want to point to something that means that's empty. So in this case, if I were to have a linked list at the beginning, and we are to put some data onto that linked list. We got some data, and then we are putting the node value. Let's say the node value in this case, this is pointing to the next one, which is going to be 1. So it's pointing to, if this is 0, okay, so if this is 0, it is pointing to, like, let's say the next node. So let's try to visualize this here. So over here, I'm going to put the data. So we have some data, and over here we have basically the pointer to 2, let's say, right? And so on and so forth. And the value and the array index of this is obviously going to be 1, right? So this is going to be the array index 1. So basically, when the linked list is empty, the value of first empty will store 0. So first empty is going to be going ahead and storing 0. Okay, first empty is going to be going ahead and storing 0. I think I could increase the font size a little bit. Let's select this, then do it. Yeah, makes it a little bit easier to read everything. So first empty, sorry, it's not going to be 1. It's actually going to be, first empty is actually going to be stored in 0. Because initially we're not going to have any data in this linked list. So the empty list starts from the first node itself. Then once we enter our data, then that's implemented. So it says here that this is the first node in the empty linked list when initialized, which is index 0. That's initially, that's the case. The global variable first node stores the index of the first element in the linked list. There's no data in the linked list when it is initialized. So it is initialized to -1. So in this case, it's going to be first node is -1. That means this is the first node. Once we increment a data, this is going to be incremented to 0, followed by 1, followed by 2, followed by 3. So this is not a traditional linked list. If we were to kind of output it, starting from the very first node of this linked list, we technically would be outputting this linked list in reverse than we have inputted. It's kind of like a stack. So it's like implementing a stack using a linked list. So that's like an interesting concept in itself, because that makes it a little bit more time efficient if we're using a linked list instead of a stack, or it actually is of a stack. It also makes it a lot more dynamic. But in this case, again, we have a constraint that it's going to go to 20. So Again, this is for, I guess, only examination purposes, but in real life, you probably wouldn't keep it as a constraint on the linked list. Okay, so with that being said, the diagram shows the contents. Okay, there it goes. So this is like index 0, the data is at 1, and the final index, that's like 20, it's going to be -1 because that's where the linked list ends. So write the main program to declare the initial linked list, first node, and first empty. I hope I'm recording actually, yeah. So we're going to go ahead and first initialize linked list is going to be equal to, so I want to go ahead and put it as integer. This is going to be a 2D array, and it's going to be for in, so for, let's say, I in range 20, so 20 values. So now I want to do for I in range once again. So for I in range, that's going to be 20 because that's the size of the linked list. What we're going to do is we want to go ahead and do linked list bracket I, comma 0 to be -1, and linked list I, comma 1. That's going to be storing the pointer to I plus 1. So that's going to be pointer to next node, right? So that's going to be the pointer to the next node, and this is going to be just the data. All right. Now we're not done here because the very last one is also going to be initialized to, let's say, 20. We don't want that because that's where the linked list ends. So we want to do is we want to do linked list. That's going to be I0. That's going to be -1. That stays -1. I think we don't need to even do this. All we need to do is just take the very last one, and it's 1, and initialize it to -1. That's probably going to do. And then we also need to initialize first empty as 0 because that's an empty list. And we want to do is first node is going to be equal to -1. Okay, so that's going to be how we set up this linked list. So if I were to go ahead and print out linked list, it should be looking something like this, where 19 and the final one is just -1. So it's going to go ahead and point to nothing, right? Okay, so with that being said, we're done. Now, the procedure insert data takes 5 positive integers as input from the user and insert these into the linked list. Each data item is inserted in the front of the linked list. The table shows the steps and depending on the state of the, okay, so depending on the state of the linked list. So if it's full, the procedure really doesn't run. If it's not full, then we go ahead and do this. So what we are trying to tell over here is that if it's empty, if the empty list reaches -1, that means -1, that means this list is empty, meaning that if it reaches oh sorry, I forgot to print it. So if our program is reaching the very end of the linked list and it's getting -1, that means we don't have any empty list at this point. So that means we don't have any empty spaces in the list. So the part of the linked list that's actually empty is not to be found. So in this case, that's when we go and exit the procedure. Otherwise, we insert a node. So that's the challenge. Okay, so let's define insert data, and it's going to be taking an input from the user. So what we want to do is we want to do global because linked list is global. So is first empty, first node. Okay, so the values in the data is going to be updated. So from here onwards, what we want to do is we want to first take the data from the user. So we want to take an integer input, and then over here. So let's just do enter data. Okay, so now if first empty, that means the linked list full, is equal to, if it's not equal to -1, that means we enter this site. Okay. Okay, so our first job is to go ahead and place the data on the variable. So in this case, first empty is 0. So if you're taking a data, we want to go ahead and go to first empty and store that data on first empty. That's going to be step 1. I really don't know why my computer glitched, but our first job is to go ahead and put the data into first empty. So we're going to be going ahead and let's say we have some data over here, data. So we're going to be going ahead and taking this data. We're going to look at first empty, put the data, then we take the value from the data, the linked list itself, so this pointer 1, and we put it in first empty. And we take the value of first empty and put it into no1. So basically what I'm trying to say is we have some data into the first empty area of the linked list. Okay, that's clear. Like we're taking some data and we're putting it into the empty area of the linked list. Once that's done, we need to now update first node, because what does first node point to? The first node is pointing to the very first data that we have entered, the first element in the linked list. So in this case, we are implementing kind of like a stack. And the reason being, look at this. It says the index of the first element in the linked list. So this needs to be updated. Why? Because if it's not full, we insert the data pointed to by first empty, because that's like literally the empty area. So we insert this data, whatever is pointed by first empty. After that, we change the pointer to the index pointed by first node. So basically what we do is we change the index of first node to whatever is pointed to first node, right? Because we need to kind of change that. So basically, we change this to first node. Okay. So change the pointer to the index pointed to by first node. So we take first node according to the question and we update it in data, right? And then what we need to do is we need to go ahead and change the values of first node and first empty. So by this step, what they're trying to tell us is that once we have updated first node over here, that means we're pointing to the very first data that was taken in the linked list. So this is the end of the linked list. And that's the reason I'm telling you this is an stack implementation via linked list. The reason being that we are now pointing this pointer to first node. And then we're taking empty list and we want to put it into first node because we need to update the values. And empty list is going to be pointing to this very next node right here. This node is going to be pointed towards, this node is going to point it to empty list. Okay, so what happens is this data is now coming to empty list. Then what is happening is this data is going to the data array itself. So let's just do it like this, right? And what we're trying to say is that this data will be coming to this value right here. I can't place it, but I guess you get the point, right? So this data is coming to this, not this one. It's like it got attached, but I'm trying to tell you is this right here, okay? So first pointer is coming to empty node. So if it sounds confusing, the steps are we first implement the data into whatever is pointed by first empty. Then we change the pointer to the index pointed to by first node. So we want to change this index, whatever is pointed to by first node. And then we need to change the values of first node and first empty. So that means they're telling us to swap these values. And first empty is obviously not going to sit empty. We need to go ahead and do this repeatedly for 5 positive integers. So that means we need to go ahead and increment first empty to the next available free space. So we need to take this pointer and put it in first empty and take this into the first node. Because again, once we put the data here, we're putting first node over here once again, because that means we're putting the data over there, right? That's what I'm trying to tell you, right? So that's it. So first node is going to be basically 0 in this case. So let's try to implement this. So first, we take linked list, and in first empty dot 0, we put the data as instructed by the question. Then in the linked list on the first empty, comma 1, we put the value of first node. Change the pointer to the index pointed by the first node. Okay, so we change this value to the first node. Now what we need to do is we need to go ahead and change or increment the value of first empty, because we need to know what the next empty list is. So basically first empty is going to be the next value in the linked list, which is going to be first empty, linked list, first empty, and 1. So that's going to be the following value. So it's coming to first empty, which is 0 in this case, and then it's taking the value in 1. That means in the second, in the 2 dimension of the array, the second dimension of the array, and putting it in first empty, because it now needs to point to this, because this area is empty, and so forth, right? So before we do that, isn't it better that we take this and do it beforehand? because again, we need to put the value of first empty into first node because the question tells us to update these accordingly. So what we need to do to kind of accommodate for that is we take this following line and put it in to the, so let's just call it next empty. Okay, and let's keep it that way. Like this is going to be storing the value of the first empty. So now we have first node. So now we can go ahead and easily do first empty, and that's going to be going ahead and storing. So we've got first node and first empty. So, or we don't even need that actually, do we? But if you do keep this is going to be making it easier. Okay, we actually don't need this variable at all. What we could just simply do is we can do first node equal to first empty, because now what happens is after I put a data in the empty list, the pointer needs to point to wherever that data was initially there, right? Where that data initially was there. So what I'm trying to tell you here is that by this line of code that we're first putting it into the empty space, and in the empty space's next node, in the next node value right here, we're putting in first node. What do you mean by that in this? So we're trying to go ahead and do is, in this case, the value was -1. If we put it in the first space, so first node has a value of -1 initially, that's going to be in empty list, and so forth and so forth. The reason being that it's instructed in the question. The question specifically never tells you why, but they're actually implementing a stack through this. And we're going to get into it very soon. I'm just going to show it to you very quickly. So first node is ultimately going to be first empty. And basically first empty can automatically be linked list. Oh, we cannot do that. The reason being we're changing first empty 1 to the value of first node. So we really actually don't know that. So that's why we had stored it in empty. So we're going to be storing it in next empty, right? Because this was a temporary variable. And this is going to do the swap for us. So once that's done, now we got to do is go ahead and do for I in range, because we need to do it for 5 data. So we can just put this as 5 and just call insert data. That's it, right? Because then this function becomes dynamic. We can call this as many times as we want. It's not only limited to the question like it says 5 positive integers. Okay, so with that being said, let's try to visualize this one more time. Let's see if it kind of makes sense. So we've got a initial linked list. Let's say we've got 2 boxes here that represent it, and I'm just going to draw a line here just to show the connection. Okay, so this linked list and this list are empty. So initially, the index of this linked list is obviously going to be 0, and the initial of this linked list, the index is going to be 1, right? So first pointer, the first empty is pointing to 0, so that's first empty is initial pointer, and first node is pointing to -1. Okay, so the question states that we first need to put it in first empty as usual, because that's the next empty spot. So if we take data, okay, you're taking one data and you're taking it and putting it into this. Then we change the pointer to the index pointed by first node. So the value over here, the data, which was pointing to, let's say, this value right here, is now going to be taking first node and pointing to first node. Okay, so basically the pointer to this is going to be -1. And that means this is not going to point to anything. So this becomes the end of the linked list. But that's not going to help us. So what we need to do is change the values of first node and first empty. So how do we change it? First empty is obviously going to be pointing towards the next empty space. That's 1. So what we do is we take the node value of this, which is pointing to 1, and store it in first empty. And since we are also going ahead and modifying first empty, we store it in a temporary variable. And then what we do is we take first node and change it to first empty, because we're incrementing 1 over 1. So first empty is pointing to the next node, and first empty is pointing to the next node, and first node is pointing to the current node in this case. So what happens is the question is telling us to change the pointer values to a current node instead of pointing towards the next node. And these pointers are current node pointers, and first empty is a separate variable on its own that's going to be pointing towards the next empty spaces. And that's how they're implementing a stack. And we're going to be getting a glimpse of that onto the next question. Procedure output linked list outputs the data of the following linked list. Okay, so let's go ahead and create output linked list. Outputs the data linked in the order. Okay, so again, this line is still the same, so you're just gonna put it here. So the question says outputs the data in the order by following the pointers from first node. So that's why we were doing that. Following the pointers from first node, we're gonna go reverse. Okay, so first we need to check that if we reach the end of the linked list. So let's say n is equal to false. Now we need a way to iterate over the linked list. So let's go ahead and store the value of first node into a temporary variable known as current, and we call it first node. Okay, because we're going to start from the first node. So what we do is while not end, so we don't reach the end, we go ahead and print out linked list current. We print out the data and we update the current pointer to point to the next node because we want to update the next node. So current is going to be linked list current 1. So what happens in this following line of code right here is we're checking that after we go ahead and output the data, we take the node of this and take it to current pointer. That means now current pointer, so if we have a variable current pointer, or in this case current, so we're just going to do current. So current was initially pointing to this. Then we take the node value from this and put it in current. That means it's pointing to the next node. So in this case, it's going to now be pointing to this. But since first node itself is being incremented to go like this, current is actually going to start from the first node itself. That means from the back of the linked list. So it starts here and then it backtracks because again, we stored the first node value in a reverse order, right? So that's why it's going to go ahead and point towards this, then point towards this. So that's why it's going to be a stack. So now current is pointing to this, okay? So with that being said, that's going to be 1. Now, before we do that, we also need to go ahead and check that if, our current pointer is -1. So we update it and then we check that if current is equal to -1, we make end equals true. So that's going to be exiting just like that, right? So let's take a look at this. Amend the main program, insert data, then output linked lists. Okay, so we want to first call insert data, which we already did over here, and then we want to go ahead and do output linked list. It's always best or good practice to have your functions together in the code, and then we're going to go ahead and call output linked list. So this is the calling of the program. So let's try to do this. So enter data. So we have got our test cases 5, 1, 2, 3, 8. And there we go. It's okay. I think we have slight issue over here. We've got 5. It's doing 3, 2, 1. And then it's blacking out to 0 at 1. I think something went a little bit wrong with our logic. I'll see what happened. So current is linked list 1. Well, not end. So end is initially false, as it needs to be. So current is first node. Okay. Let's check this. So if it's not equal to 1, that means the linked list is not full. So next empty will store linked list first empty 1. So that's a temporary variable. Then in the first empty 0, we store the data. Okay. Oh, we did take the input from the data. Okay. So data. Okay, fine. That's great. Then we've got linked list first empty. That's going to be storing the value for first node, and the first node becomes first empty, and first empty becomes next empty. Okay, great. So we're manipulating the values accordingly as required. Then we have end is false. Then we've got first node in this case. So we've got 5, 1, 2, 3, 8. just for testing purposes, what I'm going to be doing is I'm going to be going ahead and printing out the linked list to see what's going wrong. In the linked list, we've got 5, 1, 2, 3, 8. So 5, negative 1. Oh, it's storing 1 in this case. Okay, yeah, 1, and that's a 0, then followed by 1. So it's pointing to 0. Then we've got 1. It's pointing to 1, so it's backtracking as expected. So it's going to go from 3. So it should be storing the value of 3 in this case. Should it? So let's kind of give it one more look on why that's actually happening. So integer data, input data, current first node, and then we've got our end that's being false. So current pointer, linked list current. So that's going to be doing. So it's starting from first node. So data input. So we've got first empty. We do next empty linked list. So we put it in first empty as instructed by the question. First empty right here. I hope I'm recording actually because I don't want to miss this. So first empty. So first empty, then we've got in 1. That's the temporary variable. We've got linked list first empty 0. We want to put the data there. That's data. And on the first empty, we want to go ahead and put the first node. So first node, we want to change the value to first empty, and we want to change the value of first empty to the next empty value. Okay. That shouldn't still, like, initially first empty is going to, first node is going to be negative 0. So it is incrementing values correctly. So if current is negative 1, we just do true. Do while not end, and we do current pointer is equal to the first node. Okay, I really don't know what's actually going wrong here, but let's try to do it again. 5, so we are doing 5, 1, 2, 3, 8. So it is storing them correctly, but we're getting the output. The output is incorrect in some way. So first node, data is integer input. So if first, so if first negative not equal to negative 1, next empty is linked list, first empty 1. It looks like it's okay. It shouldn't be a issue whatsoever. It shouldn't be, because it should automatically backtrack. So we put this, and then first node becomes the value of empty list, that's 0. And then empty list is obviously pointing towards 1, so this value becomes 1, 2, and finally first node should also become 3 ultimately. 0, 0, 1, 2, 3, 4. Okay, so this is 1 right here. Okay, even if, okay, oh, this was 1, 2, 3, 4, 5. Yes, this is 6, so this is actually correct. Should be working. Let me just go ahead and debug this quickly. Okay, I just found out I wrote a 1 here that's actually outputting the pointers instead of outputting the data. So we need to put in 0 here. Now our code should be fine. So 5, 2, 1, 3, 8. Now look at this, that it's outputting 8, 3, 1, 2, 5. So see, it's like a stack. It's outputting it in reverse order. So that's going to be it. So that should be the first case of the output function. Okay, so let's move on to next part, which says remove data. Removes a node from the link list. The procedure takes the data item to be removed as a parameter. The procedure checks each node in the linked list, starting with the first node, until it finds the node to be removed. The node is added to the empty list, and the pointers are changed accordingly as appropriate. The procedure only removes the first occurrence of the parameter. So it could be multiple, but we're only working with one. Assuming the data being removed is in the linked list. So it's always going to be in the linked list, so we don't need to worry about it. What I want to do is def remove remove data, and it's taking a parameter data, so that's going to be it. obviously we're going to be taking the global parameters right here. So that's going to be global. And let's try to visualize this problem and let's see what happens. So assume that we have 3 of them. We're going to work with just 3. All right, and then they're connected to each other. We know their values, right? Okay, so they're connected with each other and they have certain amount of data. So what we want to do is we start checking the linked list from first node. So in this case, that's going to be, so if you're doing first node. So in our case, the first node is going to be in the reverse order, right? So it's going to be starting from here and it goes and backtracks till it finds it. All right. So what we want to go ahead and do over here is we want to first go ahead and check that if it's available over here, like if it's the first occurrence of the data. If that is the case, then what we want to do is we want to go ahead and take the pointer of this. So let's say we take the pointer. So what is going to be the pointer for this? The pointer is going to be, so basically we just do. So we're going to take the pointer. And in this pointer, we want to go ahead and this pointer is going to be pointing towards the empty list. Okay, so we want to take this pointer over here. Okay, and so this pointer is actually pointing to this, right? This pointer needs to go ahead and point to this. So we're going to take the value from this and put it into pointer. So we're going to take the value from this and put it in pointer. So that's our first shot. And the pointer is going to be pointing here. Now this over here is discarded, right? That means now first node is shifted here because pointer is pointing here. So what we could just do is assign the value of pointer to first. But the problem is, what we want to do is we want to go ahead and change this to empty list, right? Because this needs to point towards the empty lists and so forth and so forth. So what we want to do is we want to go ahead, because if this is the empty list, like this is going to be like the very starting value, like this is going to be the first empty list, that's going to be the first area, we can just go ahead and update it. And for the empty list, for the first node's empty list, what we want to go ahead and do is we want to go, so basically we've got first node over here. So since we have got first node in this case, so first node is going to be the current pointer, and we know that first empty is storing the value of the next empty list. So this is equal to the next empty space. So since that's the case with first empty, we want to go ahead and take the value of first empty and store it in to the value of first node. What I mean by that is, for example, like we've got first node here. So first node is like being, so first node is going to have the value of first empty. And why is that? What's the reason for that? Because this is now an empty list. So what we need to do is we're going to take this first empty and put it in first node right here. Okay, we're going to take this empty and put it into first node. That's the main task. So we want to go ahead and do is we want to take first empty and we want to go ahead and point it towards this first node right here. So we want to take first empty and point it towards first node. So first node is going to be containing the value of first empty, and first empty, what needs to happen there is it needs to contain the value of first node, because this was first. Why isn't it pointing towards? How do I kind of point it? But like I think you get the point. What I'm trying to say here is that this first node needs to point towards first, because this thing is now empty. And the first node is going to be pointing to the next node, obviously. So that's going to be storing the value of the current pointer. And this is only the case if this is like the first data. What if we don't have it in the first data and it's like probably the second or third? So we need to search for that. Right? So how are we going to be going ahead and searching for that? So basically what we want to do in this case over here is let's try to code it slightly so that you get a better representation. So if I want to say that if linked list first node 0 is already equal to the data, that means we found it in the very first instance. We want to go ahead and do is want to take linked list and I'm going to take its first node, to take its 1, and point it to first empty, right? That's our first job, because what's going to be happening is first node is pointing towards first empty. So this points to the next empty space in the linked list because we're adding something to the empty area of the linked list. That's like a separate line. You might want to check out my linked list video for that. So that's a separate line. So we want to go ahead and do is we want to change, like it's kind of like Doctor Strange's space-time, like you're dividing it. So first node is now pointing to the next area in the empty list. Okay, but if you're doing that, we are also losing the value of first node in this case. So what I want to do is I want to go ahead and do it into a temporary variable known as current, and what I want to do is linked list because it was the current value, and I want to take the first node and I want to put the 1 so over there. Okay, great. So now from here, first empty. So first empty is going to be holding the value of first node. By that, what I'm trying to mean is that first node where the value previously existed, all right, where the value previously existed, that value is going to be in first empty because now that part of the linked list, right, just like we saw, this part of the linked list is empty. So we need to store the first node in first empty because that's the starting of the empty list. And first node is going to be pointing towards the next area. So basically it's going to be pointing towards this now because it needs to go back, like first node needs to shift here. So first node needs to store this value. So what we want to do is want to now change first node into current. So this is if the data was found in the very first instance. What if it's not found in the first instance? So if that's the case, let's do an else statement. And if you want to say that if first node, in this case, if we want to do first node or first empty, we're going to do first node because we are searching for each node. So that's why we're going to do first node actually. What I'm going to do is I'm going to put it in, so previous. So we need to have two variables, one to keep track of the current pointer and its previous pointer. So what we want to do is we also want to have current, and in current we're going to be starting with first node, obviously, and then we kind of loop through to check if we find the data. So while linked list current dot 0 is not equal to data, and we also want to check that if it hasn't reached the end. So current is not equal to -1. But if you don't want to do this, that's also fine because again, the linked list will have the value certain. So that means we need to keep track of the previous pointer. So we just put previous equals current. And current is going to be basically the linked list dot current dot 1, right? So by this, what happens, or what I'm trying to, is my spelling correct? Yeah. So what is happening over here in this case, I hope my spelling is correct, yeah, is it loops through the linked list until it finds the area where the data matches or if the linked list ends. This condition isn't necessary because the question has constrained us that the linked list is going to be having the data that we want to remove. And this checks that when we have found the data, that means we know its previous, like the previous pointer to that data and the current pointer of that data, right? We know both of them if it's equal to data. Now we know each of their positions. So what we want to do is let's do if, although this is not necessary, but again, we also need to kind of check for that. So linked list current, because that's why we exited this loop. Since this is out of loop, even if it doesn't enter the loop, it's kind of going to go here. So we kind of need to do this secondary validation check as well. So if linked list current 0 is equal to the data, that means we have found it. The reason I'm using this line is because what if it ends and it still hasn't found the data? So if it sees that the data hasn't been found, then nothing is going to be returned. But again, we don't need to do that. So linked list, so the previous pointer, okay, the previous pointer is going to be storing linked list current. So previous is going to be storing the current value of the linked list. Okay, it is not necessary, but you could change the data of the linked list to -1. Since the question hasn't mentioned it, I'm not going to bother doing it. Linked list, so that is going to be my new empty list. So I'm just going to do current 1 is equal to first empty. And first empty is going to be pointing towards current because that's it. And current.1 is going to be pointing to the next. So what's happening here is, what if the data, so I'm just going to remove all of this. So what if the data was like, so this is current. So what if the data was technically found here, right? If the data was found here. So what does it mean by previous? So previous is going to be current, and current is changed. So current is going to be this one. Okay. What if the data was found, let's say, here? That's what I'm trying to say. Like, we've got more, but we're finding it here. And this would be previous in that case. Let's do text. It's a little bit easier to kind of mention. Or you could even, if you're holding current to be this, then this would have been the previous. Like, it wasn't found in the first. Let's do it this way. So we have found the data in the current position. It's not in the previous one. Okay. So what happens is previous 1 is pointing towards current 1. Okay. So the previous area of the linked list is pointing towards the current one. That means current is pointing towards this, right? Current is pointing towards this linked list. So we take that pointer and put it to previous. So now what happens is previous is actually pointing to the next one, not current. And so that's why we do current ones. We take the pointer from current. Now current is going to be turning into the first empty list. So let's say we have empty list. That's going to be the starting of the empty spaces. So first empty. So that's going to be the starting of the first space of the empty list. So let's say empty list was pointing to some other linked list over here. But what's going to be happening is that is going to be now pointed towards my current, because that's where the linked list is starting, because we're changing current to the first empty, right? And first empty is going to be changing to current because that's where the empty list starts. So this current is the new empty list. Reason being that current is now empty. So we need to point empty list towards current. So that's how the linked list is now updated. So this previous is a completely different linked list, and this current and empty list is a totally different linked list. That's why we put empty into first current. So that's how we have updated the entire linked list. Okay, hopefully that's clear. Hopefully you will watch the video again to just get it. So now we want to call remove data. So we want to call remove data with the parameter 5. So, and we want to use the word after. So we want to go ahead and do is call remove data with the parameter 5. And we want to go ahead and print out the word after. And then we want to also again do output linked list. So let's see what happens. Okay, so we are removing it. So the first test data is 56895. So we want to do 56895. So as you can see, it only removes the first instance of it, but it doesn't remove the last instance, right? The reason being that if it's in the if statement, that's it. It does the if statement and it never does go to the else, right? So, and we also have it while current data. And again, if there are multiple instances of the data, one of the conditions are fulfilled and it exits the while loop. It does not continue the entire program. So we're only removing one instance of the entire code. So, I mean, one instance of the entire element. So let's do it for the second test data. Why is my terminal broken? Okay, so we got 10, 7, 8, 5, and then 6. So as you can see, 6, 8, 5. So again, we removed the instance 5 and it only outputs the instance of 10. Okay, so hopefully the linked list question, even though it was a bit lengthy, it's kind of clear. So hope you guys catch up in the next video. I'll be trying to solve the 2023 papers because those aren't actually out on my channel very soon if I do get the time. Till then, see you in the next video.